Welcome back. So we left looking at a plug. Now, the next part of the lesson is going to be looking at the fuse. We're going to look at what the fuse is for, how it works, and what other types of fuses there are. So here is an animation of a fuse working. So from this, you can see what its structure is. It's usually a glass tube filled with a piece of wire. And when a large current is passed through it, you can see exactly what happens. It heats up, and when it gets really hot, it glows red, and then it melts, and then it breaks. So everything I've just said there is very simply how a fuse works. And the point of a fuse is a safety device. If the current gets too high for any reason, because of a fault or a problem, the circuit breaks, the fuse breaks, it cuts off the electricity, and it stops damage to you, and it stops damage to the appliance itself. You'll notice the fuse is always attached to the live wire, so that if there is a problem, the circuit breaks before the electricity can get into the appliance. The electricity comes in from the power station here through the fuse, it goes to your fridge or your TV or whatever, it goes all the way around in a complete circuit, back to the blue wire, back to the power station. So the fuse is here to break the circuit before electricity ever comes in. So here is the information summarized. The fuse is a safety device which breaks the circuit if the current is too high. Here is the circuit symbol for a fuse, very important to remember this. Here are some typical fuses. You'll notice they have different values. These are the usual ones you'll use in your house, 3 amps, 5 amps, or 13 amps. The fuse contains a thin wire which melts if the current is too high, breaks the circuit, and so electricity is unable to flow through the appliance. And here is a picture of a broken circuit. So what fuse should you use? So supposing you blow a fuse in your home and you need to replace it, what fuse do you use? So here is a label from a food steamer, and on this label we get information. We get told what voltage it needs, what frequency it needs, what power it works at. Now immediately you can see that this is not an English appliance. How do I know it's not an English appliance? Well, mains electricity in England is 230 volts, 50 hertz. So this is not what English electricity is. So this wouldn't work very well in England. But if we're in America, where this is taken from, which fuse would I use? Well, we need to firstly work out the current that is going to be flowing. So from last lesson, power is current times voltage, which means current is power divided by voltage. So power divided by voltage, which means 900 divided by 120 gives us our current, which is 7.5 amps. So we can choose between a 3 amp fuse, a 5 amp fuse, and a 13 amp fuse. Which one do we need? Obviously, we need a 13 amp fuse because it needs to be high enough this current will be able to flow without melting it, but not so high that it could be dangerous. If we pick like a 100 amp fuse, that would be really dangerous because 20, 30 amps could still cause problems. Now, what we haven't talked about so far is the earth wire. Why is there an earth wire? Well, if you have a metal appliance like your cooker, or maybe parts of your car, etc., what happens if there's a problem? What happens if inside the live wire touches the metal case? That will be really bad, because then if you touch the metal, you are going to be electrocuted. The electricity is going to go through you, through the ground. It's going to pass over your heart. It's going to disrupt the electrical signals of your heart, and it's going to kill you. So what does the earth wire do? Well, the earth wire is always connected to the metal case, so that if there is a problem and the live wire touches the metal case, so the whole thing is live, the electricity goes through the earth wire and back to the power station. It sort of creates a short circuit, which means electricity would rather go through the earth wire than through you. So here is the information summarized. So you can pause the video and take some notes now. There are other types of fuse. In your house, you might know where these types of fuse are. These are resettable fuses. So we will look at these in more detail when we look at electromagnetism, but they have a magnet inside that works with electricity and electromagnet. And if the current gets too high, it breaks the circuit and flips this up. And then after you've waited, a few minutes for it to cool down, you can flip the switch back down and you can reset the circuit. So these are useful because they're resettable, they're reusable, and they also work a little bit faster than a standard fuse. So we've got two layers of protection. You've got this in your house, and then every device that you use that has a plug also has a fuse in it as a second level of protection. Now, you might be saying, hang on, sir, I've got a plug for my mobile phone and the earth pin, which is this one here, is plastic. Well, plastic doesn't conduct electricity, so are you lying to me? Well, no. Some appliances don't need an earth pin. Now, that's only true if the appliance is what we call double insulated. If the appliance is so safe and made of something like plastic, never conducts electricity, you don't need an earth pin. Otherwise, anything that is made of metal or could conduct electricity must have a metal earth pin. So if it's double insulated, you will see this symbol on it. So if you go and look at your mobile phone charger, you might see the symbol on it. If you go and look at other things that have plastic earth pins, you might see the symbol on it. Okay, so this is only ever the case if they have plastic cases and they're basically super safe and super tested. Here is a hairdryer that has that symbol on it. So pause the video now, make some notes. This is the end of the lesson, so you can complete watching the video now and finish the final set of questions.